Hello. Very good afternoon, good evening, good morning, whenever you are watching this lecture. Now, in today class, I am going to start one of the most important topic. And over here, if I am not wrong, two questions will be there from this topic, direct in mains and advance minimum. Don't worry, very important topic. And the name of the topic is electrophilic aromatic substitution. Electrophilic aromatic substitution. Very important topic, trust me. If you will not complete this topic, don't go for JEE exam without completing it. Jokes apart. And I am not saying just so that you will watch this video and my view will increase. No. You have already JEE paper. See the JEE paper and judge what I am saying or not saying. Okay, sir. Understood. You are saying we are trusting on you. Okay, thank you for that. Electrophilic aromatic substitution. First of all, I will take one benzene ring. Instead of aromatic compound, you already know. Aromatic substitution, I am going to do addition. What do you mean by that, sir? Suppose I will take one benzene ring. And over here, I will take Br2 plus. Br2. And we know that this Br will break as Br plus and Br minus. And now I am going to break this bond. How, sir? By heterolytic cleavage here. Minus plus. What it will become? Ringa, chinga, pinga, hinga, linga, bhatinga. Over here Br. Over here Br. Over here Br. अब now this situation, what I have done over here is known as electrophilic aromatic addition. Electrophilic aromatic addition. Sir, you have written the heading electrophilic aromatic substitution. You are teaching addition, not teaching. I am saying you electrophilic aromatic addition is not possible. Why it is not possible? Because over here we have a benzene ring and you see this is aromatic. And after giving the product, it will become non-aromatic. And we lose the aromaticity. We lose the aromaticity. It means whenever we are doing electrophilic aromatic addition, it is not possible because while doing the electrophilic aromatic addition, we lose the aromaticity. Okay, so we will do substitution. What do you mean by substitution and addition? Addition means, suppose this is benzene ring. One hydrogen. A Br will come, attack here. Double bond will go and Br will attack here. This is called addition. Substitution means benzene ring, hydrogen. This hydrogen will go outside and with this place Br will come. So addition is not possible because it will lose the aromaticity. Benzene ring will lose the aromaticity. So electrophilic aromatic substitution is not possible. Electrophilic aromatic addition is not possible. Only substitution is possible. Okay, sir. We understood what you are trying to say. Okay. It means, again, don't get panic and confused. 3 to 4 minutes give me to start this topic. Electrophilic aromatic substitution I am going to start. In that I have told you why addition is not possible, electrophilic aromatic addition, because benzene ring will lose the aromaticity. But if we will do electrophilic aromatic substitution, suppose this is benzene ring, one electrophile will come and this electrophile will substituted over here. So what happened? From here hydrogen will go and electrophile will come. Ab over here they have not loses the aromaticity. This is known as electrophilic aromatic substitution and it is possible. There is no problem in doing the electrophilic aromatic substitution. Question arises, how the substitution is happen, sir? Tell me the reason behind it, the mechanism about it. So see, first of all, mechanism understood. What is going inside electrophile, you know, na? हाँ sir, electrophile we know. Electrophile is not positive charge. Electrophile has vacant orbital. Means BF3. CCl3 or AlCl3, like that, etc. Or those who have vacant d orbital is also called electrophile. In hydrocarbon I have dictated already. Now, understood what is the mechanism going on. First step, what I will take one benzene ring. Here, double bond. Now what happened? After seeing this electrophile, suppose I will give electrophile over here as a positive charge. After seeing this electrophile, this double bond will break. And this double bond will break like this. It will break like this anyway. It will get negative, it will get positive. Electrophile will attack this negative charge here. Acha sir. Means what is happening? Just understood. Don't get panic and confused, sir. Sir, you are making us panic and confused. We are not make panic and confused. Okay. Now what happened? Inside it, you will get ringa, chinga, pinga, hinga, latinga. Over here, double bond present. Over here, double bond present. Over here, one hydrogen is already present. Over here, plus charge coming. And over here, electrophile is attacking. After the attacking of electrophile, what will happen? This plus charge is started doing the resonance, pi sigma positive. So another structure coming, resonating structure, ringa, chinga, pinga, hinga, double bond here, hydrogen and electrophile will be as it is. Over here plus charge will come. Again it will do resonance and it will become ringa, chinga, pinga, hinga, linga. This double bond as it is, this will come here, here hydrogen and electrophile. It means first it will form a cation and after that they will do resonance. If you will see this all resonating structure, these all are resonating structure. If you will draw their resonating hybrid structure, what you will say? Ki, sir, over here we have benzene ring. Acha sir, yes, we have benzene ring. In that benzene ring, here double bond coming, here double bond coming, here double bond coming, here double bond coming. Coming? Which place coming? Here and here double bond coming. Any problem in that? By mistake I have written here, don't get confused. Ore pia, here not. Double bond, see na resonance you will do. Don't get panic. Double bond. It will go here, double bond here and here. This double bond will come here and positive charge will come here. By mistake I have written there double bond. So where double bond is there? Here and here. It means double bond is surrounded like this up to this. Up to this double bond is there. And over here hydrogen is there. Over here electrophile is there. Where the plus charge is going? All the double bond plus. Here plus, then after that here, then after that here. It means each and every place the plus charge is coming. Again understood. First, electrophilic aromatic substitution. Electrophilic aromatic addition is not possible because benzene ring will lose its aromaticity. Electrophilic aromatic substitution, electrophile will come and it will attack on the benzene ring. What will happen? Electrophile seeing it will do heterolytic cleavage, minus plus on the minus charge. This electrophile will attack and after that plus charge will do resonance and after doing resonance I have drawn the resonating hybrid structure and this resonating hybrid structure is known as carbocation formation. Carbocation formation. Coming na carbocation. It is also known as sigma complex. These are the names. Don't get confused. These are names. This is also known as aranium ion. They will ask what is the intermediate coming in electrophilic aromatic substitution. They will say carbocation or sigma complex or aranium ion or Wieland intermediate or benzonium ion. Benzenium ion. So these are the name of this. Resonating hybrid structure that is happens in the intermediate of a electrophilic aromatic substitution. Now tell me, their rate will be increased by electron donating group or electron withdrawing group? Sir, plus charge is there, plus charge needed, electron donating group. What are electron donating group? Like OH, like CH2 minus, like NH2 minus, like O minus, like OCH3, like 3-degree alkyl, something like that, they will give electron donating group directly proportional to electron donating group and inversely proportional to electron withdrawing group like NO2, like CN, etc. You know that, na? I have already dictated in isomerism part. The first we have understood electrophilic aromatic addition, substitution and their mechanism, and in the mechanism the compound form is carbocation, sigma complex, aranium ion. These are the same, all name are same, or Willand intermediate. Anyone or benzenium ion, all are the same name of this compound, and it is their rate is directly proportional to the electron donating group and inversely proportional to the electron withdrawing group. I hope you understood what I am trying to dictate. Now, slow. This topic is easy also, but you have to understood it. Now, over here, what I am going to dictate, it is only coming in JEE Advance, not the mains syllabus, but still this topic, but understood. Don't worry about it. Sir, advance, why I will do advance? No, everything do. Sometime mains will also do problem. Now, some reaction will happen in electrophilic aromatic substitution. Either that reaction will be reversible or that reaction will be irreversible. That reaction will be reversible or that reaction will be irreversible. If irreversible reaction is there, then rate of C6H6 is equals to C6D6 or is equals to C6T6. Irreversible means those who will not come back. So over there, either hydrogen is there with benzene ring, or deuterium is there, or tritium is there. In all the three cases, rate will be same. What is same? Rate of reaction, it will be same. Deuterium, tritium and hydrogen will not increase the rate of reaction. But if it is reversible reaction, na, over there you have to check two things. Either electrophile will be very stable, or you have to check gaseous product. Gaseous product means, suppose I have the electrophile of 3-degree carbocation, or I have the electrophile of iodine plus, these are stable electrophile, or I have gaseous product like SO3, CO2 or N2. If these things will coming, then we will say कि in this situation the rate of C6H6 is more than C6D6 is more than C6T6. Means sometime what they will do, कि over there irreversible reaction they will write, and they will give benzene ring. One benzene ring they will attach 6 hydrogen, one benzene ring they will attach 6 deuterium, one benzene ring they will attach 6 tritium. They are asking which one of the following is have more rate. We will say all three have more rate, but they will give sometime reversible reaction, and they will give electrophile as carbocation or I plus or SO3 or CO2 or N2, and they are asking which has more. So then you will say in this part, hydrogen of benzene ring has more rate than deuterium than tritium. Understood this part? Any confusion? No, sir. So we have understood electrophilic aromatic substitution something. Now we are going to see some application of electrophilic aromatic substitution, EAS. Now I will say EAS. Those who have studied up to now, they now started understanding it. Means, suppose I have taken one benzene ring over here. Suppose I have taken one benzene ring over here. Ringa, chinga, pinga, hinga, linga, bhatinga. Benzene ring written or pH written, phenyl, na? That you know, pH and H, phenyl. Acha. I am going to react this. Something I am going to write over here. बहारो फूल बरसाओ 1 2 3 4 and 5. Over here, suppose I have taken concentrated HNO3 in presence of H2SO4. Over here, electrophile will come NO2 plus. Suppose I have taken X2. X2 will be Cl2, Br2, as well as some Lewis acid. Lewis acid like AlCl3, like FeCl3, like that Lewis acid I have taken, etc. Over here electrophile will come X plus. Now suppose I have taken only concentrated H2SO4. In this situation the electrophile is coming SO3. Suppose I have taken RX alkyl halide in presence of AlX3. Over here the electrophile is R plus. Suppose I have written RC double bond O X in presence of AlX3. In this situation the electrophile is RC double bond O plus. Understood. First of all, concentrated HNO3 plus H2SO4, NO2 plus is the electrophile. Cl2, Br2 in presence of Lewis acid, X plus, yani Cl plus, Br plus, I plus will be the electrophile. Concentrated H2SO4 only, then SO3 will be the electrophile. And if I will take alkyl halide, Rx in presence of AlX3, then R plus is the electrophile. And RC double bond OX, X means chlorine, bromine, iodine. Then RC double bond O plus is the electrophile. If this is the electrophile, what is the product coming? Sir, pH is there already. H will go and NO2 will come. Over here, what is the product coming? pH X. Over here, pH SO3H. Electrophile is SO3. But after some time, H will coming. How? Slowly it will come. Over here pH R, whatever be the electrophile, that one will attack na. हाँ sir. pH C double bond O R. This process of adding of nitrogen NO2 is known as nitration. A small space, so I am writing a smaller handwriting. This place, this halogen adding is known as halogenation. SO3H will add, that is known as sulfonation. And R will attack, that is known as alkylation. And C double bond O R will attack, that is known as acylation. And this alkylation and acylation is a Friedel-Crafts reaction. It is a Friedel-Crafts reaction. So sometime they will ask directly what is the electrophile in concentrated H2SO4 in presence of HNO3. You will say NO2 plus. What is the electrophile in X2? Lewis acid concentrated H2SO4 or RX or RC double bond OX. So what will happen? What is the name? Everything I have dictated, and I hope you understood this part. Now we are going to see the next part of this topic. Now we are going to see the next. Over here, so I am just benzene ring taken, but in place of benzene ring I will take, suppose over here, chlorobenzene, and then I will have to attach NO2. So I will say one NO2 attach over here, and then one NO2 attach over here in the para position. So that part we are going to see. Only benzene ring, then we will attach only one time, but already chlorobenzene, any sol or bromobenzene, something like that, then we have to check it is attacking on ortho position or meta position or para position. Means I am going to dictate you the next part of the topic, that is called orientation. Orientation means where it will attack, on which place, how it will be oriented. Suppose I will give you the AC and saying please orientated this in the room, staff room or classroom. So you will orient means you will place that AC at a particular place where it is required. It means suppose there is a simple benzene ring, so electrophile will attack over here. But in this benzene ring there is one group G that is already attached. Now some electrophile will come, E plus. A problem is that sir, I didn't know it may be the situation is that in this benzene ring, according to this group, either it will attack on ortho position, ortho para meta, so you know that. Acha, it is a possibility sir, in this benzene ring it will attack on meta position. We didn't know na. How we will know that, sir? I will dictate that only. Or there is a possibility with this group they will attack on para position. This you know that na. If this group is there, then according to this group, this is ortho, this is meta, this is para, this is meta, this is again ortho. So there is a possibility that electrophile will either attack on ortho position or on meta position or on para position. Sir, how we will know that where it will attack? So G situation. In G situation, case number 1. How we will know that it will attack on ortho, para or meta? For that we will have case number 1. Case number 1 saying कि if G will be electron donating group like Cn, OH, something like that, then the electrophile will attack on ortho and para position. Electrophile attack on ortho or para position, in which major product is always para. Major product is always para. If case number 2, if G group will be electron withdrawing group, G will be electron withdrawing group, then electrophile will attack on meta position. Where it will attack? Meta position. Only one place attack, that will be the major product. Case number 3. Case number 3 will be something like that. I have written na कि G will be Robin Hood. Robin Hood. What is Robin Hood? Robin Hood are especially chlorine and bromine. Why, sir? Because it will show minus I effect, and as well as it has lone pair, so it will show plus M effect. So those who will show minus I and plus M, both, that type of things is known as Robin Hood. So if Robin Hood type things, Robin Hood is not the name. What are the things you will get Robin Hood? Sir, either you will get the Robin Hood as Cl, Br, or you will get the Robin Hood as N double bond O, or you will get the Robin Hood as CH double bond CH COOH. More than that you will not see. These are the Robin Hood. Robin Hood is the name I have given. It is not chemistry term. Now either it will have plus I, minus I and plus M, but it will attack on ortho and para position. And in that, electrophile will attack on, or electrophile attack on ortho and para, and in that major product will be para product. Means only in the case of electron withdrawing group it will attack on meta position. Other than that, every situation it will attack on ortho and para, and ortho will be the, para will be the major, ortho will be the minor. Now I am going to write some questions and we will solve that question line by line. Some question we will see over here. You will say, sir, OCS3. Now what you will do, have to do na, whenever you have to check, suppose you forgot कि sir over here where the electrophile will attack we didn't know, so try to make positive here, just the place where the electrophile is there, where the group G is there. Here you will make positive in your mind, here you will make positive, here you will make positive, here you will make positive. Now see, this positive is stable or not? हाँ sir, lone pair giving this stable. Over here not stable, तो meta directing. Over here not stable, meta directing. Lone pair giving stable, तो taking, तो not stable. Over here lone pair giving stable, lone pair giving stable. Over here lone pair giving stable. It means make the positive charge, check, it has lone pair stable, it means ortho and para. Not, then meta. Or a different way, कि it is electron donating group. What it is? Electron donating group. And if it is electron donating group, then electrophile will attack on two position. OCH3, over here electrophile will attack, and OCH3, over here electrophile will attack. This is known as minor product and this is known as major product. So instead of drawing both, I am going to draw only major product. Any problem? Only one. Why I will draw? Over here, where the electrophile will attack, sir? Sir, CHO. CHO means it will attack on meta position. Sir, over here where? In meta to no major minor, na? Only one product is there. Acha sir, over here what you will say? Sir, over here COOH, electron withdrawing group. Where it will attack? On meta position. Over here, OH, it will attack on two position. One on ortho, electrophile, and one on para. Which one is major, sir? this one is major, this one is minor. So I hope you understood it. This is electron withdrawing group. Where it will attack? Electrophile. Sir, electrophile will attack on meta position. Acha, over here, sir, electron donating group. Where it will attack? Sir, 2 position. NH2, over here, electrophile, and NH ortho position and para position. NH2, over here, electrophile, ortho and para position. It is minor product. It is major product. Over here, sir, it will also attack on 2 position. Chlorine will show minus I effect with benzene ring. But whenever any electrophile will come, it will also always act as a electron donating group. So this is minor, this is major. Over here, problem is that, sir, you can't attack on para position because someone is already sitting on para position. So this time, only one place is left. Meta to not coming because it is para and ortho directing group, and on para already someone is present. So ortho is the major product only. No problem. Why? Because something is already present on the para. So how will attack on para position? So only one product coming. So I hope you are understanding this. Now, case of haloarenes, what I have said, haloarenes means halogen is there. I have said that whenever halogen is there, always it will attack on ortho and para position. But attacking is ortho and para, and checking is meta. Arey sir, what you are saying, not getting. Acha, see it. Case of haloarenes. What is the case of haloarenes? See, haloarenes will be something like this. Ringa, chinga, pinga, hinga, linga. Over here, chlorine is there. Now, we have to check 2 things in haloarenes. One, reactivity. And another one, orientation. Orientation means where the electrophile will attack. So what you will say? If orientation we have to check, so this will act as a, chlorine will act as a plus R or plus M of chlorine. Robin Hood. And where it will attack? Ortho and para, in which ortho is the, para is the major product. But someone will ask reactivity. Then at that time, it will show minus I effect of chlorine. Which effect? Minus I effect. And in this situation, it will become deactivating group. Deactivating group. What do you mean by that, sir? Means whenever I am saying which one is more reactive, I will give example also, don't worry about it. But I hope you understood whenever they will ask where the electrophile will attack, the ortho and para, the chlorine will act as a plus R or plus M, and ortho and para attacking, or para will be the major product. But someone will asking reactivity. So which situation we have to check? Minus I effect of chlorine deactivating group. It will deactivate the group. Means I am saying like this something. Ki electrophile attacking, to this example you have seen. Ki ortho and para. Sir, reactivity means, suppose I will write over here OH. Or I will write over here, where OH. Now I am saying, check their acidic strength. What you will say? Sir, this H will go, it will become minus. Now whenever you are checking the reactivity, you will say it will act as a minus I effect. Something attacking, then plus I. Something acidity, basicity, at that time it started taking the electron. It will act as a minus I effect. Understood now? Acidic strength, basic strength. At that situation, chlorine will try to take electron. But something to attack, then ortho and para position. Now, line by line, up to this you have understood? Sir, understood. Very easy. You are saying very important. This is important? Yes. If you are finding it easy, it is the proud moment for me. Now, we are going to start the first topic called nitration. You have said, sir, nitration, NO2 plus is the electrophile. How? We didn't understood it. See, we have to find first electrophile. What is the reagent you are using? HNO3 plus H2SO4. In this part, what will happen in the case of nitrogen? Automatically, one will act as a base and one will act as an acid. Acid-base reaction. What will happen? Acid-base reaction. Acid-base reaction. Automatically, one will act as an acid, one will act as a base. What will happen? Acid will give H plus and base will take that H plus. So what you will get? It will become HSO4 1 minus, and base will become what? H2 na. So H2NO3. I am writing this in a proper way. H2O means, if you will see like this, you will get confused. What is the structure of this? HNO3. HNO3 structure I am drawing. HNO3 structure is N double bond O OH. Now this acid will give H plus, where this lone pair will take H plus. Because of that, what it will become? N double NO3 na. Over here coordinate bond O. HNO3. What it will become? Over here coordinate bond O. Over here OH, and one electrophile H is attacking. From here what it will happen? This will go outside. Once it will go outside as a water. Water is a very good living group. Water. H2O will go outside. What it will become? NO2. It is taking the electron plus. So like that, electrophile is coming. NO2 plus. Understood? Now in nitration, you can use lots of reagent. It is not the fixed reagent. HNO3 and H2SO4. We can take also. What are the things we can take? Either you can take any mixed acid, HNO3 plus HNO3, or you can take dilute HNO3. Dilute HNO3 H plus means H2O and HNO3 acid base reaction. Third, you can take concentrated HNO3. Fourth, you can take NO2 BF4 and NO2 ClO4. This reagent you have to know. These all reagent will give the electrophile as NO2 plus, and these all reagent will do nitration. Understood this bakbas? Sure short? Huh sir, very easy. What is the problem in that? Okay sir. So now I have some more question that we are going to see. If we will see the questions first. Acha sir, CS3 make plus rule. Here plus, 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 here plus. Now every place I am doing nitration only, concentrated HNO3 like that. This plus is stable by plus I effect. This plus is stable by lone pair because halogen will give ortho and para. This is lone pair stable. This is not stable. Meta directing not stable. Sir, lone pair stable. This is lone pair stable, sir. This is lone pair stable. Those who are stable, that is ortho and para directing group. Don't miss. Don't go faster. See here. Now over here what will happen, sir? Again two product will come. Ringa, chinga, pinga, CS3. Over here NO2 will come. And then CS3. Over here NO2 will come. This is our major product. This is our minor product. Ortho is minor. Over here in the case of chlorine, again nitration. Over here NO2 will come. Over here X NO2 will come. Again this is the major. This is the minor product. Over here again you will get the two product in case of OCS3. OCS3. Over here NO2 plus. Over here OCS3. Over here NO2. Now over here it is again minor product. It is again major product. Suppose you will take COH. This is meta directing group. So it will come only one product. Over here NO2, and this is the major one only. Suppose you will take CHO. This is also a meta directing group. So NO2 will come over here. Now if you will take OH with dilute HNO3, OH with dilute HNO3, then two product is coming. Over here OH and NO2, and another one OH and NO2. Every time para is coming major, but over here intramolecular hydrogen bond, intramolecular hydrogen bond. Because of that, ortho will become major and para will become minor. But if you will use concentrated HNO3, see over here you have taken dilute HNO3, then ortho and para directing group. But instead of dilute HNO3 with phenol, you will take concentrated HNO3, then NO2 will attack on all three positions. Means over here also, and over here also at a single time. No ortho and para product. Means OH with dilute HNO3, ortho, para. Ortho major first time after a long time, and OH with concentrated HNO3, it will form all three places. Two places ortho and one places NO2 para, and this is known as picric acid. This is known as picric acid. Understood the point what I am trying to say, or confusion? No sir, very easy sir, very easy. We understood it. It means this picric acid, but the problem is that it will give poor yield. Means coming, picric acid to coming, but coming very poor yield. Acha sir, if I have to make this good yield, how I will do it? Means again understood. With phenol especially, if dilute HNO3 given, then ortho and para. Ortho is major first time. When concentrated HNO3 given, H2SO4 not given, also no problem. Then picric acid, but it will give poor yield. Sir, I want a good yield. What I will do, sir? Do one thing. Suppose how to get better yield of picric acid. How to get a better yield of picric acid, sir? So do one thing. First you will take phenol, and with that phenol you will use first reagent, concentrated H2SO4. Concentrated H2SO4 will attack on three position. SO3H, over here SO3H, over here SO3H. And in the beginning I have written ki JEE advanced only, but written na कि whenever SO3 electrophile coming, so they are reversible, it can reverse back. So what happens? Reversible reaction means it will go back. It means once you will give SO3, then use over here concentrated HNO3 in presence of H2SO4. This will give NO2 plus as a nucleophile. SO3 will remove. Reversible reaction na. So SO3 will remove, and NO2 and NO2 will come. So this is the intermediate, and this will give good yield of picric acid. Understood? Where I have told JEE advanced, what I am trying to say, कि suppose any place bad yield coming na, so try to do sulfonation first and then do the reaction. Sulfonation will attack and they will go outside and they will give good yield. Okay sir, this you are trying to say. One more question left. Aniline, what you will say? In the case of aniline na, three product coming. Over here NH2, it will attack on ortho position also. NO2 nitration, it will attack on meta position also in case of aniline, because aniline, phenol are very high electron donating group, and high electron donating group will increase the electron density in the ring. In this will come 51%. Ortho will come 47%. This is ortho. This is para. And meta will come 2%. But coming. In the other case, to meta not coming. But in this case, meta will also come as a 2%. So I hope you understood how to get a better yield of picric acid and each and everything what I am trying to dictate. So this is all about nitration. Now we are going to see the next part of the topic, and the name of the topic is called sulfonation. What is the name of the topic? And at the last part you will definitely do. In the last I will dictate you which of the following will do SN1, which of the following will do SN2. In the class I have told na ki short trick I will give, and I am planning to give the short trick over here in the video. Those who will see this video, they will get 2 questions from electrophilic aromatic substitution, and 2 questions from that, 2 or 1, 3 questions will be covered in that video. I will make this video as a very good video. Okay sir. Over here what you are taking? Concentrated H2SO4. What is the structure of that? S double bond O, OH, OH. OH. Now, what will happen? It will do self-ionization. And while doing self-ionization, it will form S double bond O, double bond O. That is coming SO3, and this is the electrophile. Over here, what are the reagent you can use? Either you can use concentrated H2SO4 or you can use OLUM, OLUM. This is H2S2O7. H2S2O7. This can be also written as SO3 plus H2SO4. This is the formula for OLUM. Anything you can use from this. Understood? Now, on this basis, we are going to see some more questions. Then sulfonation also done. Now, we will see some question over here. Sir, CS3 is there. So, it will form two product. Over here, CS3. Over here, SO3H will attack ortho position, and CS3 over here SO3H will attack on para position. This is minor, this is major. Understood? Acha, over here NH2 is there. In the case of NH2, now what will happen? See, first of all NH2 is there, and I am drawing only major product. SO3H will come. Then this H will go upside like this. NH2 will become NH3 plus, and SO3H will become SO3 minus, and this is known as Zuiter ion. What it is known as? Zuiter ion. In the case of NH2. Sir, what about ortho? In this part we will not see ortho position. Now, first we understood ortho, para, major, minor. Over here Zuiter ion coming. Now, third part I told you SO3H is a reversible reaction. NaOH, OH minus will come, SO3H will remove. It means SO3H will remove easily. Anyone will come, they will say H will. Acha, H plus SO3H will remove, and hydrogen will come. No need to show hydrogen, you can show it. Consider again, it will form two product. Cl is there. Over here SO3H, and Cl is there. Over here SO3H. This is major, this is minor. Understanding the point? Means whenever SO3H is there, something is attacking. The don't attack on earth position, para position, may happen. Remove SO3H. SO3H is a reversible reaction. It can go out. But other things like aniline will be there, NH2 will be there. It is not going out. Only SO3H, CO2 like that. I have written in the beginning JEE advanced part. Last, OLUM, benzene ring. Over here no ortho and para. Why? Because it has only one attacking, no ortho para position, and that is known as benzene sulfonic acid. Benzene sulfonic acid. So sulfonation also done. Now next part we are going to see is known as halogenation. Acha sir, what you have written in the beginning, that you are going to dictate line by line. What are the reagent used, how it will do that. Over here X2 will be there. X2 will be break as X minus X plus. Over here you will use some Lewis acid. Lewis acid like AlCl3, FeCl3, etc. Lewis acid, or you can use this also, Fe, FeX3, AlX3, anything. I have written in the top also. These Lewis acid are halogen carrier. These are halogen carrier. And they will give X plus. And this X plus is the electrophile. This X plus is the electrophile. Understood the point? Everyone. Halogen carrier means what? It will take one halogen, minus is there, so it will become AlX4 minus, or it will become FeX4 minus, or it will become FeX. Like that, they will take the X minus to himself and let the X plus outside as a electrophile. Okay, sir. Now we are going to see some questions that I have written regarding this. Now we will see the questions of halogenation. Over here I have written some questions. Acha, X2. What will happen? X will attack. I am not writing ortho and para both. I am writing only the major product. Ortho will also come. Major product. X is coming. Over here, already one X is present. Another X will come over here. Any problem? Why? Because they are electron donating group. Ortho will also come. I am writing only para. Major product. Over here, OCH3, their name is anisole. Good name, so I have written X over here coming. COH, electron withdrawing group, sir. Over here on meta position X will come. Now understood. Over here CS2 na non-polar. And whenever phenol is there and non-polar is there, then it will only form two product, ortho product and para product. Every place ortho will also come. Don't get confused. Does I have to write it? No sir, leave it. No sir, we understood ortho is the minor product, so you are not writing it. Para is the major product, so you have written it. Ortho also coming. But this place don't write other things. Only one. Meta to no possibility na. Whenever OH is there and non-polar solvent like CS2, only CS2 is there, then ortho and para. But if polar solvent will be there like OH, then Br will attack on all the three position. Like that picric acid na NO2 attacking OH के साथ, तो over here it will attack on the all three position, and this compound is white precipitate. Sometime they will ask, phenol will react with bromine and H2O, one white precipitate is coming, what is the name of that compound? So sir, 2, 3, 4, 6 tribromophenol. 1, 2, 3, 4, 5, 6. What is the name? 2, 4, 6 tribromophenol. So that white precipitate is tribromophenol. But for NH2, either polar solvent or non-polar solvent, it will always and always attack on the all three position. But OH, non-polar, orthopara, and polar, all three place. This is also white precipitate. Understanding the situation? Everyone, any confusion? Now sir, question arises in our mind कि sir, I want to attack only one position here. I don't want to attack on all the position that you have given. Means I am saying first ortho and para coming, or para is the major, ortho para, para is the major, ortho para, para is the major, meta to meta. Over here polar, non-polar solvent, ortho para, para is the major. Polar solvent in case of phenol, white precipitate. But NH2 either polar or non-polar, both cases white precipitate. Now question arises, 8th number, कि sir, over here I have taken NH2. What the reagent I will use over here so that I will get two product in which one product is coming on the para and that I will get as a major product. What I will do? I don't, because NH2 is highly activating, Br here. I don't want all three places. I want only at para position. So what you will do? You will do this step, and this question asking, what is the step you will follow? First you will take aniline. NH2 is there. You know that it is highly activating group. Aniline is a highly activating group. What you will do? First you will react that aniline with CH3COCl in presence of pyridine. CH3COCl means CH3 double bond OCl. Pyridine means benzene ring nitrogen. Now you know that this is acylation. This will break, plus will come. After that you have to attack this with Br2 in presence of CH3COOH. And after that you have to attach this with dilute H2SO4 in presence of H2O. Then you will get aniline. And now in this situation, all three places bromine will not attack. It will attack one time at ortho, one time at para, and para will be the major. Sir, this reaction we have to learn. Yes, but how it is coming, I will dictate you. First you have taken aniline, react that with CH3, C double bond OCl in presence of pyridine. Line by line use. In presence of pyridine, use this. N is there. Now what happens? It will break, it will get plus. Now once the plus is coming, problem is that this nitrogen has a lone pair. So it will not do acylation or alkylation. I have written in the class, Friedel Craft, alkylation or acylation cannot be done by aniline, phenol. Reason you understood? Lone pair. That topic also I will teach online. What will happen? This will attack on the lone pair. N has already one hydrogen, two hydrogen. On this lone pair, C double bond O, CH3 will come. Because of that, this nitrogen will get plus charge, and this plus charge nitrogen will take the hydrogen, and hydrogen will go outside. You will get ringa chinga pinga NH double bond O CH3. What will happen now after doing this acylation? Acylation to not happens. It is not attacking on ortho para. It is directly attacking on the lone pair of nitrogen. It will do lone pair, sigma and pi resonance. So instead of giving the electron to the benzene ring, it is doing resonance also. So it will become moderate activating. Moderate activating. Once it will become moderate activating, try to react this with Br2 in presence of CH3COOH. Now it is moderate, so Br will not attack on all the position. It will come NH double bond O CH3, and Br is attacking on para position. But you need NH2 na. So again you will use dilute H2SO4, dilute H2SO4 in presence of H2O. What it will do? It will take all this part, hydrogen will come, and this final product you will get para bromoaniline. And this way you are able to get, very important question, you are able to get the one place substitution of bromine in place of 3 place also. If you are not using this all reagent, only Br2 and H2O, or Br2 or CS2, or Br2 or CS3COH, you will get a white precipitate, and that white precipitate will come as a 2,4,6 tribromoaniline. Understood? Now, another question I am going to take. Next question. Yes, now we are going to see the question. I have written whenever phenol is there and reacting with Br2 in presence of H2O, it will give a white precipitate OH, Br, over here Br, and over here Br. Sir, but you have written SO3H. What will happen in this case? Just now written SO3, CO2 are a reversible reaction in the beginning JEE advanced part. So over here OH, again Br will come. SO3 will go moe moe. Over here Br. Still it will give white precipitate. Sir, over here COH and SO3H. Then again COH will give CO2 na. CO2 na. And CO2, SO3. See. Don't get confused. Oh, sorry. Over here CO3 and SO2 na. My mistake. Sorry, my dear friends. Over here you have seen in this part. Over here I have written sir, CO2, N2, like that coming. Then don't get confused. Just remove it. Acha, okay sir, I understood it, what you are trying to say. Means over here COH will also go, SO3H will also go, and you will get over here OH, over here Br, over here Br, over here Br. Understood? The student will see COH, they will attach Br over here. Answer coming, one option will be there like that. Your life will be moe. Remove all CO3, NO2, N2, like that coming though. Now, so this is all about sulfonation, nitration, and halogenation. Now we are going to see little bit left, half an hour or 1 hour it will take maximum to complete it. I don't want to make it 2 to 3 videos. Next part we have is the topic called alkylation. And which alkylation? Friedel-Crafts. I will write. I am going to write over here Friedel-Crafts reaction. Friedel-Crafts reaction. In Friedel-Crafts reaction, first we will have is alkylation. In alkylation, what will happen? First of all, find halogen, means electrophile, and all this reaction I have written in the beginning, one place. It will break, it will get negative, it will get positive. And you are using now over here Lewis acid like ALX3 type. What will happen? Carbocation is coming, and then over here ALX4. I have told it is the halogen carrier type. Acha. The first important point you will write कि in the case of alkylation, carbocation is formed. If carbocation is formed, then to 200% rearrangement will happen. Acha. If rearrangement will happen, So it will not occur, does not occur on strong deactivating group. It will not occur on a strong deactivating group in ring. What do you mean by that? Suppose you will take NO2 over here, strong, it will not happen. Suppose you will take CN over here. Suppose you will take COOH over here. These three will not do alkylation. It is a strong deactivating group. Next important point. Polyalkylation, handwriting is okay, takes place. Polyalkylation means more than one place alkyl will come. Poly, 2 to 3 means, suppose I have taken benzene ring. Over here I have taken RX and ALX3. What happened? R will attack over here. R. That's it. Understood the point? So this is the part of alkylation. And in this basis of alkylation, we will see some questions. But question arises, sir, for alkylation, what are the reagent we can use? And that is very important, that you have to learn. What are the reagent? You will see 1 time, 2 time, definitely, ma'ams and sirs. Don't miss it. Very important. Acha, some time a student is asking, sir, when rearrangement will take place every time? So this point also you can add. Ki in case of weak Lewis acid like FeX3, no rearrangement. No rearrangement means AlCl3 rearrangement, yes. FeCl2 rearrangement, yes. BF3 rearrangement, yes. FeCl3 rearrangement, no. FeBr3 rearrangement, no. By mistake I have written FeCl3 in the class time, so don't worry about it. This will not do rearrangement. Now, what are the reagent you can take? Either you can take RX in presence of Lewis acid, or you take an alcohol also plus H2SO4. This will also do alkylation. R plus will come, R plus will come every place. Electrophile is R, like that. Nitration, sulfonation, I have written different reagent similarly. Third, you can take alkene in presence of H2SO4. Fourth, you can take alcohol in presence of Lewis acid. And this all reagent will give what? R plus as electrophile. So don't use too much brain. If you will see anything like that, you have to attack R plus in that. Understood the point what I am trying to dictate or not understood? Sir, understood. Now we have some question that we are going to solve. Over here, if we will see the question, sir, in this part, this will break ALX3, FeX3 is not there, plus will come, this plus will do rearrangement, here it will come, and after rearrangement, it will attack from this position. If it will attack from this position, one side 1, 2 carbon, one side 1, 2 carbon, one side 1 carbon, coming answer. In this part, sir, CH2Cl2. In this case, what you have to do, you have to take this as 2 mole and this as 1 mole. Then ALX3, what it will form? pH, CH2, pH. How, sir? We didn't understood it. See, over here, first what will happen, ki from this na CH2, Cl is there, Cl is there. One Cl will go, plus will come, benzene ring, CH2, Cl will come. I have taken phenol as 2 ring. I have taken this as 2 mole. Again this will go, plus will come, and this plus will attack over here. You will get benzene ring, over here CH2, and after that pH. So I have written this answer. I am writing all the possible questions. See it properly. Understood now how I have done it? Over here, this reagent, this point, this will give what? Sir, this will give H plus. This H plus will attack over here. It will become H. This will become plus. This total will go outside. It will become plus. What is coming over here? This on this ringa, chinga, pinga, here, plus. It will do rearrangement? No, sir, already happy. This plus will attack over here. What you will get? Benzene ring. After that, 1 carbon, 2 carbon, 3 carbon. How many carbon? 3. So 1 carbon, 2 carbon, and 3 carbon. And these two are coming on the same position. So 1, 2. Understood? Over here, this will go and this plus will come. This is attacking benzene ring. After that CH2 and pH means benzene ring only. Over here alkene plus H2SO4, it will break as minus and plus. This will give H plus. H plus will come here and this plus will attacking here. What you will get? Benzene ring. After that there plus 1 carbon, 2 carbon, 3 carbon. Understanding the point? And this is very important example. This is called chloral. How it is happening? Now don't learn it. Just understood. CH, CH3. This will come one side. This side benzene ring and over here Cl. This side benzene ring. This example mechanism is little bit big, so I don't want to make you confused. Just learn their name is DDT. DDT means dichloro diphenyl. Yes sir, that only. Trichloroethane. Dichloro diphenyl trichloroethane. And sometimes they will ask how you will form DDT. So I have used all the reagent to make you understood how to do these types of question. Understanding, see everything very properly, and my guarantee as a teacher I will never give you the bad concept of JEE mains. Very important, that much important, you can't believe it. Now next part of the topic is acylation, and this is the last. Then I will dictate you which one will do SN1 faster, SN2, E1, E2, means how we will judge it is doing SN1, SN2 like that. Okay. Acylation, na, you will get R C double bond OX, and this X in presence of, over here no rearrangement, rearrangement, over here alkyl only rearrangement. It will be break and X minus will come, plus will come. It will become R C double bond O plus, and it will do resonance. How? I will tell you. Plus is there, oxygen has a lone pair, they will give the lone pair, it will become RC triple bond O, oxygen will get plus. So resonance is happening inside it in acylation. Question arises, and ALX over here, ALX4 minus coming over there, no worry. Over here, what are the reagent we can use, sir? We can use either RC double bond OX in presence of ALX3, or we can use RC double bond OC double bond OR in presence of ALX3, or it will use RCOOH carboxylic acid in presence of H2SO4, and anything you will use, all will give RC double bond O plus as a electrophile, and after doing resonance it will become RC triple bond O plus, like that. Understood? Now on this basis we will do some questions. Life is interesting. Now we are going to see some questions of acylation. First question. Acha sir. Over here Cl will go, plus will come, and an ortho and para both it will attack, but I am drawing only para position. Na? Don't get confused. Major product I am drawing. Over here AC2OAC means what? Cell. CH3 C double bond O C double bond O CH3, it will break, plus same thing will come. AC2OAC it is written as, it is ACOAC, so AC2OAC. CH3 over here again double bond O and CH3, like that also I can write, na, same thing, na. Ha sir. Over here third part, say H2SO4 will give H plus will attack over here, this water will leave, it will become plus, and it will attack like this previous question. 1 2 3 carbon, so 1 2 3 carbon, and over here double bond O. Understanding the point? Acha, just now I have dictated you ki electron withdrawing group, strongest electron withdrawing group, it will not do reaction. Friedel-Crafts alkylation or acylation, no reaction. In the beginning I have cut it. Acha, over here see, AlCl3 in presence of this, what happened? This will go, it will become plus. अब question arises, here you will attack or here you will attack. So check, it is electron donating group, and electron donating group will be very good for para position. So according to this, it is ortho, it is meta, it is para. So where it will attack? On para position. Like that also you have to think. So OCH3, because confusion na, both are same side, two answer they will give. So 1, 2, 3, 4 carbon is this time. So 1, 2, 3 and 4 carbon this side, double bond O. Why it is attacking here? Because of electron donating group. So I hope you have understood what the bakwas I am trying to dictate you. Now last part of the topic, and then I will do questions in the last after completing it, and that topic is SN versus E. It means nucleophilic substitution versus elimination, and over here most of the student getting confused. So see, whenever there is a polar protic solvent means something like that, H will be present, hydrogen is present. Whenever polar protic solvent is there, it will always do SN1. Whenever polar protic solvent and heat is there, like 50 degree, 60 degree or heat is written, it will do E1. Whenever they will give some base like this is very important, and it will make you very easy. Base minus like RO minus or alcoholic KOH, like that they will give na. So check ki if it is 2 degree and 3 degree, carbocation means 2 degree or 3 degree alkyl is there, then it will do E2. And if it is 1 degree, then it will do SN2. But thing is that on 1 degree plus no branch is there, unbranched, like that. If it was 1 degree, suppose Cl over here, now if branching is there, then no SN2, then E2 again. Means don't get confused. This I am writing you the very easy tricks. How we will know that it will do SN1, SN2, E1, E2. So whenever polar protic solvent, SN1. Polar protic solvent plus heat, E1. Base like this, and on that base 2 degree and 3 degree is there, then E2. 1 degree without branch, SN2. Similarly, next part, if base is there and heat is also there, over here only base without heat, base plus heat is there, it will do E2 mechanism or it will do E1 CB if electron withdrawing group is there. And in hydrocarbon I have already dictated you what is SN1, what is E1, what is E2, what is SN2, what is E2, what is E1 CB. But I am over here giving you how to judge it. Now if some nucleophile is there, not base, like aqueous KOH or RS minus RSH is there, I am removing hydrogen making minus, like that is there. So it will do SN2 whenever 1 degree and 2 degree is there. It will do E2 whenever 3 degree is there. And it will do SN1 whenever 3 degree and polar protic solvent. With this they will give H2O, ROH. The polar protic solvent it will do SN1. And these short tricks, looking short tricks, but trust me, it is the most interesting part. If you understood it and try to solve the question on this basis, this will help you a lot to understand the topic. This is all about electrophilic aromatic substitution. Try to do lots of questions I have done on this basis. You want to do some questions, so I am giving some homework as a question. Doubt, ask in the comment box. Now these are the questions I have written. You will try this. Check over here polar protic, this is polar protic, this is polar protic, over here heat, so it will do SN1, it will do E1, like that you will judge. And these two questions you will try to do it from your side. Not getting, ask in the comment section. And this is all about the electrophilic aromatic substitution. And trust me my dear friends, this is very important topic of all time. 2 questions you will get directly from this without a single question. And most of the things you will see on the YouTube, you will not get directly these types of topic, electrophilic aromatic substitution. So see it, any doubt, ask me on the comment section, or at the last 9267937718 is my calling and WhatsApp number. But please don't call, give me a message, any doubt, anything, I will dictate you. Bye, have a nice day, enjoy, take care, stay home, stay safe.